So what we do, our mission is to expand market access and increase demand for Canadian wood products through the excellence in codes, standards, regulations, and education. So maximize and protect market access, make wood and building systems easier to use, and position wood as a favorable material. So what WoodWorks does, what Haley and I do every day is we do continuing education. So we work with architects, engineers, developers to help assist them, to train them, show them what's advancing in the timber industry. We are no cost project support, so we are a free resource. So if you are working on a timber project, please, and you have any questions, any structural questions, any code questions, please reach out to Haley or myself. Woodwork program, then we are free. So we'll show you beautiful timber pictures and that you don't sell on timber. They're just a free project support for community architects and engineers. And then we have one bunch to name units. This is our team. We do have a new hire. We haven't got a shot yet. She's the case of Ottawa. And our executive director is Stephen Street. He's been here at the past 2 conferences, so you may look familiar to you, but so how can we help? What we do? We do presentations, like I mentioned, we use YouTubers as well too. So if you are looking at doing a project, rec center, community center, we can give you a lot of project examples, see if it's possible to we do workshops. We did one a couple of years ago in festival in Valhalla and Viking group actually there. So we have next to the architect in the Bay Area. Technical resource hub, online tools which I'll go through now, and then the technical support. So some of these free tools that you can see. So this first one is the effective art calculator. So you can see it's an online tool you can put in your climate area, and this will help you go through, I mean, 16,000 wall assemblies or over 16,000 wall assemblies that you can click at. Oh, there we go. There we go. Okay, maybe I won't yell as much. Please tell me to quiet down in the other room. So yeah, you can look through 16,000 wall configurations. The durability assessment provides valuable guidance for choosing between repairable walls. It's a really nice, neat tool, easy to use, especially the R factor to see which products you have access to. So some of the suppliers in the area. So very, very cool tool. And Haley will talk more on the durability side of this. Beam calculator. So this is designed for solid timber, glulam, structural composite lumber, I-joist. So you can design beams on walls. Yes. Dimensions calculator. So this is for moisture content shrinkage. So if you have timber that has been sitting out of the rain, you can check the moisture reading on it, and then what the drying conditions are going to be, and you're going to see how much your timber has shrunk. So it might be a good idea to let it dry out or whatnot. So this will help you calculate that shrinkage. Board foot calculator. This one's more common for if you're selling lumber or project estimating. It's just that's a way to calculate your board foot. Carbon calculator. This one's probably one of our most popular tools. So building with wood, you are avoiding a lot of greenhouse gas emissions compared to concrete and steel. So this kind of gives you a nice example. It takes about 2 minutes to put your project in, and it'll give you the results. So it'll talk about greenhouse gases avoided, total potential carbon benefited. It gives you some real life equivalents. So taking cars off the road, or how many homes you could heat per year with using wood instead of materials. Go check, this one's probably my favorite as well too. So if you have a project and you're not quite too sure if you can build it out of timber, if you have to do concrete or steel, depending on the building area, number of stories, and the building sprinkler, you can put in your information. It takes about 30 seconds, and it'll tell you if you build a lightwood frame, mass timber, EMTC, which we'll get into a little bit, and it will give you case studies as well too. So it'll give you real life projects that would be similar to the project that you're working on to give you some helpful direction. And then our fire resistant rating and SCC tool. So when you're building multi-story projects, you have suites above each other or adjacent to each other. This will help give you assemblies with fire resistant ratings and SCC ratings as well too. A bolt selection tool, this one's really new, but it's a great tool. Instead of going through all of those different charts, this actually has more options than the charts do in the wood design manual, and it's pretty easy to use as well too. This is our woodwork software. Unfortunately, this is not free. It is free for plans examiners. Okay, perfect, that worked. And inspectors. And it's also free for students. So if there's if you're teaching students some education as well too, this is a great tool because it is free. So we have sizers. So you can do elements for gravity design. So beams, joists. You can build with the concept node, you can build your whole building and help kind of size out the timber that you're going to be needing. Connections, so it'll show you some custom connections that you can do. And then lateral shear walls, so once you get into multi-story, to help with that. So we have training videos, tutorials, user guides. Just reach out to Haley or myself, and we'd be happy to put you in the right direction and show you how to use the software. Technical publications, so Woodworks is a resource program of the Canadian Wood Council. I think we mentioned that. So we have the Wood Design Manual, which is one of our biggest ones, Engineering Design in Wood, Introduction to Wood Design, and coming soon we have Advanced Wood Engineering Manual, which hopefully by the end of the year, Engineering Guide for Wood Frame Construction, span books. So this is what contractors would be using on the field to help determine the span that you can go with joists and that. Permanent wood foundations, we do have a guide for that as well too, which could be very interesting as well. And those are our tools. So I'm just going to take you down a path down memory lane here about the building code. So 2009, the BC code allowed for 6 stories, so mid-rise. It took us 6 years to get that into the National Building Code and the Ontario Building Code to raise up 6 stories for light wood framing. 2020, the National Code adopted 12 stories of encapsulated mass timber construction. 2022, Ontario adopted it. So we do have, if you were by our booth, we do have some guides for that as well too. It allows for, when you're in mid-rise combustible, it allows for much bigger footprints than you would be allowed to and taller buildings. So it's kind of competing more with concrete and steel for those larger buildings. 2024, BC code allowed for 18 stories of EMTC. And 2025, Ontario adopted the extended EMTC provision. So now you can build up to 18 stories with encapsulated mass timber construction. Okay, Haley, I'll pass this over to you.
Thank you. Oh, thank you. Okay, so I'm going to talk a bit first about lightwood framing. So this is the 6-story combustible construction that Brock was mentioning that's been in the code since in Ontario since 2015. So why would you use light frame construction? I think it's like the most common housing construction type, but just to highlight that it's cost-effective way of building and it's lightweight. So it's very easy to bring to site, maneuver, small foundation, stuff like that. And if you use prefabricated components, which are becoming more and more popular, you can put these houses up very quickly. So it's actually up to 6 stories here, but it is a very cost-effective solution. Also for low-rise commercial projects, lightwood frame timber is becoming more and more popular in use for commercial projects and industrial projects as well. So just to go into a bit more detail of what the codes allow, as Brock mentioned, up to 6 stories. That's only for residential or office applications. So for other occupancies, you're only permitted to go up to 4 stories for retail and industrial, and only 2 stories for an assembly or a care facility, unless you're going into mass timber elements, which we'll talk about later. So anything other than anything bigger than that will go into either non-combustible construction or now mass timber. When you're doing a 6-story multifamily project, you are allowed to have some mixed use occupancies in the first 2 floors and still build it to the full 6-story height out of lightwood framing. So you can have some mercantile or retail kind of options on the first 2 levels, and then you can have A2 assembly occupancies on the first two levels as well. So like meeting rooms, schools, restaurants, stuff like that. And then up to the third floor, you can have storage garages, so parking garages with 3 stories of timber on top. And then if you're doing an office building, you can also have some light industrial occupancies on the ground floor as well. So like workshops and storage facilities. Up until 2023, the Ontario Code required you to have non-combustible exit shafts in these 6-story combustible buildings. So we also just like to highlight that that was changed in 2023. So you no longer have to do the extra fire rating and concrete shafts. You can now build your stair shafts and entire building out of wood. So that just makes it a lot easier because you don't have to try to get a concrete contractor in there to build stairwells for that small scope, and you can just build it all out of wood. Wanted to talk a little bit about fire safety. So for light frame construction, these buildings get their fire resistance rating through drywall that's attached to the studs. So you can get your 45-minute, 1 hour, even up to 2-hour fire ratings if you need to, just by adding drywall to the outside of the studs. And then there's lots of different requirements for like blocking in certain areas to make sure that fire is not going to jump from one unit to another or one room to another. And there are also some new kind of treatments and technologies out there that are being promoted for specifically more for construction and fire safety. So before you get all of your drywall in place, these buildings can be very vulnerable to fire or arson. So site security is one important aspect, but also there's certain treatments like barrier tech that you can get sprayed onto the timber, and that will make it much less flammable and burn slower if there was a fire risk. It would protect the property basically. So it is quite an investment, but depending on the risk that the owner or the builder is wanting to take, they could invest in that kind of a technology. And then if you're going up to 6 stories, all of these buildings need to be sprinklered. So if you're talking like single family homes and stuff like that, obviously no sprinklers are needed. But if you are going up to the 6-story mid-rise that's permitted, you need to sprinkler the buildings, which just gives that additional layer of fire security. So there is the supplementary standard in the Ontario Building Code that gives you these lists of, again, like dozens of different wood assemblies and what their fire ratings are. But you can also use our FRR and STC tool that gives you kind of a similar table, but it's just an easy digital tool instead of having to look through all these pages in the standard. So yeah, really want to plug that tool again. It's just an easy way of finding assemblies that work for your project. And then speaking of sound transmission class rating as well, so that's in the same tool. If you're doing a multifamily building, sound transmission and acoustics becomes very important. So depending on, again, the budget and the goals of the project, you could talk to an acoustic consultant to give you advice on how much kind of insulation you actually need in this building to make sure it's comfortable sound-wise. But typical best practices would be adding some kind of insulation in the floor cavity. You don't need to fill up the whole thing, but like fill it up halfway with insulation. That's pretty good for sound transmission. Isolating finishes from structural elements. So if you can put like a rubber mat or something under the flooring, that really helps with the sound transmission from footsteps and stuff like that. And then adding mass always helps to dampen sound as well. So sometimes these projects will actually put like 1.5 inch or a 2-inch topping of lightweight concrete on top of the floor assembly, and that will also help add mass and dampen the sound from transmitting from unit to unit. So again, it all depends about budget and the goals for the project. Now, talking about durability, as Brock mentioned earlier, we have this effective R calculator that has a really good function of, it kind of takes into account your climate that you put into the tool, and it will give you recommendations on assemblies to avoid or better assemblies to use based on your climate to make sure that you're not dealing with any moisture issues inside of your walls. So just as an example here, one common assembly now that continuous exterior insulation is more common is continuous foam insulation on the outside and a poly vapor barrier on the inside, shown with the red line. So this could be a common type of assembly. But depending on your climate, you could be introducing a moisture risk with this assembly because both poly and the foam insulation are non-permeable for moisture. So if water does get inside this wall, it's very tough for it to dry out. So it might recommend to you one option of using a more vapor permeable insulation on the outside like rock wool. Or it might recommend using a vapor smart barrier on the inside so that it doesn't let moisture into the wall, but it does let moisture dry out. So the effective R calculator tool will kind of give you recommendations on different options for moisture safe wall assemblies. So really quickly, I'm going to run through a few different types of light frame structural components other than just your solid sawn studs and joists, and just talk really briefly about what the differences are. So structural composite lumber products are made up of smaller pieces of wood to make kind of more dense, strong pieces of wood, and then you can make them as long as you want or as long as the manufacturer's press will allow, and it's like a more kind of effective use of the wood fiber, but it is more costly than just solid sawn lumber. So laminated veneer lumber, they actually use veneers of wood and they kind of flatten them out and glue them and press them all together. So you get this, again, really kind of thick, almost like a piece of plywood, but thick. Then you have laminated strand lumber. So this is when they actually start to carve the veneers, but then they just chip them into strands and then spray them all with glue, press them all together in high heat, high pressure machinery, and then you get this really dense fiber product that's super strong. So that's laminated strand lumber. And then you have parallel strand lumber, which is exactly the same, but they try to orient all of the strands in the same direction so that all of the wood grain is kind of going along the length of the beam or column. So again, you get a more strong product because all the fiber is oriented together, but a little bit more expensive. So the benefits of structural composite lumber, again, like I mentioned, there's almost unlimited lengths, really just limited by the press and transportation, but you can, instead of needing a 30-foot tree to get a 30-foot piece of lumber, you can make one out of these smaller pieces of wood. So again, a lot more effective use of wood fiber. And they're actually a lot more dimensionally stable as well. So you don't have to worry so much about the shrinkage or expansion with moisture content with this type of lumber. So it's more stable, less prone to kind of warping and having different defects in it. And again, they're stronger than solid sawn lumber. So you can use these in all kinds of different structural applications. And then really quick, you're probably all familiar with these ones. So we have engineered wood I-joists, which makes use of these different engineered lumber products to, again, use the wood fiber more effectively where there's in high stress areas. You can consider open web wood joists, which if designed properly, you can kind of run some of your services like piping and ducts and stuff through those open webs. So those are becoming a little bit more popular. And then obviously roof trusses are a big component. I just wanted to highlight that the Ontario Building Code now includes a QC requirement for all truss manufacturers in the province. So I think like pretty much all of them in the province are now QC certified, meaning you're going to get a high quality truss if you're buying roof trusses from one of these certified plants in Ontario. There is a list of them on the Ontario Structural Wood Association website, so you can double check that your truss manufacturer is certified, and that just means that they have to make sure that they're using high quality lumber that's to specification, and the truss plates are not being installed over defects so that they can really get their teeth in and get the strength that they need. So that's a really good development in the truss industry for Ontario. Okay.
Thanks, Ellie. So I'm just going to talk a little bit about prefabrication construction. I know at the trade show there yesterday, there was quite a few exhibitors that were here with some of these different options. So just to kind of break it down, panelized construction. This is like your wall panels, your floor panels. I'll show more about panelized construction because that's kind of what I'm more focused on this presentation here. Modular construction is when you're taking those 2D panels and you're building a 3D modular box or whatever you're building with it there. So then you can stack them on top, connect them there. Manufactured homes this is entirely constructed in the factory. So floor finishes, electrical, plumbing, and everything can be done like the picture shown here. Manufactured homes and modular homes, they're a great option. It's project to project base. It depends on some of the trades that you have there. If you have some of that skilled labor, where it would make sense to use one over the other. However, when you are using manufactured homes or modular construction, you are limited to the width of it, and you are shipping a lot of air as well too. So I'm just going to go through the panelized sections and give you some project examples and talk about some of the processes that they're doing. So these are factory built most of the time wall panels. Here's an example of one. In the workforce, it is typically when we're going to see some of these facilities, it's probably 50-50 split on the gender, maybe even more females than males in here. So it's great working conditions. You don't have delays when you're building these panels. The picture on the left there shows an automatic nailer as well too. So when you're installing the sheeting, it will make sure you're getting all of those nails in the proper location. So you have really good quality control there. On the bottom right there, that's the CNC Hundinger. This is, you can create your housing file in a BIM or your wall panels on a BIM, and then this will cut all of the timber for you. So for this, when we went to visit this site, they were able to cut a house, I believe it was in 3 or 4 hours. So do all of the cutting of the wood in that 3 or 4 hours, and then they're just assembling it. So it's really increasing the speed compared to a stick-built frame. So some examples, this one was wall panels. This was a very high performance wall panels. I know Took Tree's in the house here as well too, and they have a very similar high performance wall panel as well too. So insulation would be on there. You would have your high performing weather resistant barrier that's highly breathable, and then the smart vapor control layer that Haley mentioned on the durability side of things. So you have your complete panel there. So the bones of the walls and that will be good with these high performances. So yeah, this is just one for the Caldwell First Nations. So they were able to do 28 high performance homes. Construction started in January 2023. So hence the speed of construction, completed September 2024. So they were able to do 28 of these high performance homes in less than 2 years. Elements condos, so now we're getting taller because we do see a lot of efficiency with these mid-rise projects. If you're doing 3-4 stories, it's also a great example because there's a lot of repetition in them. So this is a developer, Pratt Homes, in Barrie, Ontario, with the timber installer Katie Clare. So they did 3 buildings, 6 stories. So these are just very simple wall panels where they just have their studs and their OSB or plywood sheeting. And then they get delivered on site and lifted up into place. So here's some finished products of the panels all being installed. And I thought I had one more, but anyways, so this is the guide to mid-rise wood construction. So there's a QR code there, or you can just reach out to Haley and myself. So that's a great resource when you're looking at building taller with light wood frame. We do have our CWC e-learning hub. So part of our program is we do lots of webinars as well too with industry experts. So we have those all recorded, and you can learn as well too through that. And if there's any architects or designers that need continuing education hours, they are certified as well too for those. There's also a mid-rise wood frame construction handbook with FP Innovations. And then there's a guide for sound installation and wood frame construction by NRC. So just to recap, I do like this project as well too. So they have a nice curved building here because a lot of times when you're thinking panelization, you're thinking boxes, but that's not always the case. It definitely complicates things, but it's still possible. So faster build times, minimize the weather delays, good quality control. Building it in a factory compared to on site where you have your lumber piles, moisture being exposed to it. Cost efficiency. It is a little bit more money right now still compared to stick frame. However, if you're building taller or you're doing more houses kind of with the same type of application, you will definitely see efficiencies in it. And if you can get in the building quicker, then that will help with offset some of that cost as well too. And then there's also funding opportunities. I believe the three here that are closed right now, but there will be more opportunities because this is something that the province and the country wants to keep going forward with because we have a housing crisis. We need to start building homes faster, and panelization is a great way of doing it. Haley, I'll pass it back to you. Oh, no, sorry, this is still my side here. So mass timber products. So we talked about lightwood frame, so we're going to get into mass timber. So solid sawn timber, that's like your heavy timber frame products that you would see. I'm going to go through them one by one here. Nail laminated timber. So there's a ton of abbreviations on these, so I'll do my best. So nail laminated timber, this is where you're putting your 2x material. If it's a 2x6, 2x8, you're putting it on its 1.5 edge, and then you're nailing these panels together. So this has been done for quite some time. There's buildings in Toronto that are 6, 8 stories, been around for 100 years in the distillery district and that. So this is the warehouse decking. So it's been around quite often. I know there's going to be a gentleman who's opening up an NLT facility here in Thunder Bay or just outside of the Thunder Bay area as well too. So you will have access to that, and you can really do this on site if you needed to as well too. Dowel laminated timber, so DLT. This is getting popular. It's coming from Western Canada, but we'll see if there's some suppliers that pop up using DLT. So instead of using all of those nails, what they're doing is they're putting these the 2x material all together, and then they're drilling it, and they're putting a hardwood dowel in there to help fasten it. So you can see in the picture in the bottom right, there's some of these larger panels being lifted and putting up into place. So this is great for rec centers, community centers, schools. Glue laminated timber. Perfect example is this beautiful room here as well too. If you look at the ceiling, so this is small wood pieces being glued and pressed together. And then there's also, you can also make this into floor panels as well too, like the other two. Right now, the University of Toronto is building the tallest wood structure in Canada, the academic wood tower. So we're actually doing tours of that project as well too, and that's going to be out of GLT. CLT, cross-laminated timber. So this is, you're putting it on the wide side. So if it's a 2x4, you're putting it on like the 3.5-inch wide. You're putting all of the pieces together, and then you're alternating. You're crossing the second layer, and then you have the third layer. So these, and then you have 3-ply, 5-ply, 7-ply, 9-ply. This has like a 2-way span as well too. So Haley will show you some of products where you would have to use CLT over the other ones. It's a little bit more money, but you do get some pretty good performances with it. So we'll show you lots of projects on CLT there. And okay, now this is your turn.
Thank you. All right, we're doing a little bit of switching back and forth here. So yeah, there's tons of different wood and mass timber products as we've shown you, and there's tons of different factors that go into choosing which one you should use for different applications. So just quick list of them here. Cost obviously being a consideration. Some of these products are more expensive than others, so you have to determine, if they're warranted and if they fit within the budget of the project. But also schedule. So some of these bigger panels and prefabricated components, they might be a little more costly, but they might help to expedite schedules to meet funding requirements or to get people into homes faster. So there's always a trade-off between speed and potentially more prefabricated offsite construction. And then it'll also depend on the needs of your building. So how big of spans do you need? Do you need wide open spaces, or do you have small repetitive units? So that'll inform which types of different products are available to you just based on how far they can span. And then obviously looking at code requirements, building performance requirements, the different systems that are in your building, like mechanical and the building envelope and how those all interact with each other, as well as aesthetics. So as you can imagine, some of these products look different than others. Some of them look like a bunch of pieces of lumber glued together. Some of them look more like veneers. Some of them look more historic with just the pieces of lumber nailed together. So it depends on what kind of aesthetic look you're going for as well. And then considering the environmental goals of the project and if you are trying to hit any sustainability kind of certifications or carbon reductions. So all of these different factors can be discussed up front and working with the design team and the manufacturers to kind of determine who's best to fulfill your project needs. So I'm going to run through some quick examples of a few more housing projects, but using mass timber this time, just for some ideas, some context, some inspiration. So this is in Toronto. It's 1120 Ossington Avenue, and it's a 3-story building built for affordable housing out of a combination of mass timber and light wood framing. So they built it in a very tight infill site, and they were able to get all of these new units in and built up very quickly. So you can kind of see they had some light wood frame panels for the walls, and then they're hoisting in the CLT floor panels. So they can make these panels so massive, and they're rigid enough to kind of hoist up into place. So they only needed basically one floor panel per unit. So this really expedites the schedule. Instead of having to go in and frame like hundreds of joists, they just lifted up one panel per unit, and then they're ready to go onto the second floor. Just here's another angle, so you can see how tight the site was as well. Wood is quite light, so you don't need super big cranes or anything like that. You can kind of drive a crane in and then hoist these into place very quickly in tight sites if you need to. Here's another example of an affordable housing project that's also a hybrid light wood frame and mass timber. So we're seeing more and more of these, and the business case is making sense for these developers to create affordable units, but also invest in these, CLT, a little bit more of an expensive product. But then again, as Brock was saying, like benefit from the schedule offsets. So this is a 6-story building, and this one was also done, the other one was Element 5 mass timber as well. So that's a mass timber facility in southern Ontario, just outside of London. And this one also used a combination of light wood frame walls and CLT floors. But then this one is, going up to 6 stories. They'd used some steel on the ground floor because they actually had some parking spaces underneath the building on the first floor, so they needed to create some bigger open spans. But they actually used CLT for their stair and elevator cores. So this building was, after the code change, they were able to build it entirely out of wood, and it just allowed them to save so much time and scheduling headaches because they didn't need to coordinate with a masonry contractor or a concrete contractor coming in and building the formwork to do a 6-story shaft before the wood was able to be installed. So it just really simplifies things and gives you a lot of schedule savings as well. So you can see on the left the CLT stair shaft, and it also gives you a really nice finished look for your stair shaft as well. So they were able to just coat that with a fire retardant coating and then leave it exposed in the stairwells. So it gives you a nice warm feel to the building as well. Here's another example of a fully mass timber housing project, the YWCA in Kitchener-Waterloo. So this was all CLT, again, fabricated by Element 5. And they were able to really make use of that speed of construction as well. This is one application where they integrated an open space concept into the building. And as Brock was mentioning earlier, there are some cases where you would have to use CLT over other products. This case, you can see there's no beams under the CLT. There's only columns and then supporting those floor panels. So these slabs, again, are two-way. They have strength in 2 directions because they're cross-laminated and the wood grain kind of alternates on each level. So if you make the spans short enough to just support the panel on each side, then you don't need any beams. So it allows you to have a really clean finished ceiling. You can run mechanical if you need to, and you can get that really big head height. So this is one of the more popular, this is one mass timber system that's really gaining popularity. And then for the rest of the building, they just used CLT walls and floors. So again, no beams. They're just running these panels in between the walls, and it went up super quickly. They also used CLT for the facade, and they actually did these in vertical panels. So you can see they just pre-cut all of the windows and doors and penetrations for exhaust or air intakes in the factory, and then they just dropped them in on site, get these installed super quickly, and then the building was enclosed. I do have a video here, if it'll work, of the construction. Let's see. Oh, thank you. So you can this is just a really quick time lapse showing you how the building came together. So it went together really quickly. Do you know the total schedule, Brock? 8 weeks total to get this 4-story building put up. So you can kind of see how quickly it all went up, and then the facade came together super quickly, and they were able to just slap the membranes on there because it's one big flat surface, and then get the cladding on quickly as well. Yeah. Yeah, so they started September, and then it was done before the end of the year, before the winter set in. So it was a really, really quick build for a 4-story building. This is an example of a study that was done a couple of years ago. It was actually commissioned by the Thunder Bay Community Economic Development Commission in partnership with CRIBE, the Center for Research in the Bioeconomy. So this was done by Studio VMA, Veronica Madonna Architects, and it was a study on the feasibility of using modular mass timber homes for remote communities. So the entire study is available at the link on this slide. I don't know if the conference is sending slides out, but we are happy to share this slide deck with anyone who wants it. So either just come see us after or shoot us an email, and we'll be happy to send it out. It's got all the links, including this study, which provides lots of great renderings of what these housing units could possibly look like, but it also goes into a financial feasibility study as well. So it actually looks into how practical and feasible these types of units would be. And then, yeah, lots of nice images as well to show you what kind of quality units you could get out of using mass timber modular. And then it does go into some detail about the plans and the systems as well. So it's a very comprehensive study that is freely available. And just wanted to highlight another kind of more northern modular housing project that was really recently completed in Espanola. So this is by Axe Building, which is one of the a newer modular manufacturer in the province. This was a 6-unit stacked modular build with 600 square foot units. And they actually integrated CLT for the floors and a nano CLT, which is just like a really thin, almost like a plywood, but it looks the same as CLT. So they used that for the under the roof trusses just to get a similar exposed timber look on the ceilings in the upper units. And then light wood frame walls and roof trusses, of course, as well. So all of these 6 units were built on site in 3.5 months after they were prefabricated in another facility with all of the kind of interior finishes buttoned up on and cladding buttoned up on site. And here's another picture of the back, so you can kind of see where on the first floor you have that thicker band around the second floor framing. So that's where you have your thicker CLT panel. And then the roof had just the thin nano CLT, and then they placed the roof trusses on top when it was on site. And here's an interior view. So you can see that nice exposed wood look on the ceiling. So that's what they can get with both the 5-ply or the nano CLT. And then you have less drywall in there too. You get this nice exposed wood ceiling. Just really quickly wanted to highlight a non-residential project because, as we've mentioned a few times, mass timber is also really good for like big open spans and things like community centers, rec centers. So we have tons more examples of those types of projects. We only just put one in here for the sake of time, but this is another project that we're really proud of. We're going to be doing a presentation with 2 Row on this project with at Technations in Niagara Falls in May with FNHC. So if anyone will be there, you can get a more in-depth presentation on this particular project. This is the Nishwaas Child Care and Family Center in London, Ontario. So this is just a really beautiful project. It's actually designed to be in the shape of a turtle. So you have some really beautiful curved spaces and different complicated mass timber systems to achieve this grand space on the inside. And you can see these really nice warm spaces inside that are great for children and for healing and all kinds of different biophilic kind of benefits to be within that kind of warm wood space. Do I have time? I think I have time to run through this quickly. What time are we going till here? Quarter two? Yeah, we'll allow some time for questions at the end too, for sure. So I'm just going to really quickly run through this. This is a fire test that we did in collaboration with a bunch of different partners a few years back in 2022. And the point of this test was to create a worst possible case, really severe fire in a mass timber test building and have no sprinklers, no fire service intervention, just set it on fire and see what would happen. So this was basically just to work with the code advancement to give them more comfort that these types of buildings are safe and they're not going to collapse in a fire. And we are also working with insurance, with fire services, with different manufacturers to just make sure that everyone is kind of learning from this test what they need to feel comfortable with these types of bigger mass timber buildings. Because as Brock mentioned, now we can go up to 18 stories. So we're getting really big buildings happening out of wood now. And there are, we want to make sure that we're doing it in a safe way. Just to do a little bit of warning, there might be some shock value with some of these photos. I'm going to show you a building on fire, but just fair warning. So this is the test structure. They built a 2-story mass timber building. It had different mass timber products from manufacturers all the way across the country. So you can see the glulam beams and columns that made up the kind of skeleton. And then we had some CLT floors. We had a GLT roof in the back. And then on the second floor, we also had a DLT roof. So all kinds of different products involved. And they were also testing some different fireproofing materials, fire stopping around penetrations and stuff like that. So here's the whole structure. They put the exterior facade on it, which was just a steel stud facade with drywall and insulation. And they actually didn't install any windows because, one, it was too expensive and they knew they were just going to break in the fire anyways. So this actually contributed to the severity of the fire too, because lots of air could get into the fire right away. So a typical fire wouldn't get out of control as quickly as this one did because they made a really aggressive fire starter and they didn't have any windows there, so lots of oxygen was getting into that fire. So they lit this, what we call a crib, on fire, which is basically like a 6-foot tall pile of lumber that they build into this giant crib, and then they put some fire starter at the bottom, light it on fire. So a couple minutes later, about 4.5 minutes after they lit that fire starter, the fire crawled up this crib of wood and then was starting to shoot flames up towards the ceiling. So you can see that this plume kind of started coming out from the crib and then kind of charring on the ceiling. Then it started to spread, so they put some furniture inside this open concept kind of office space as well. They put lots of like different wooden desks and just extra wood fuel in there, again, to make it super severe, to replicate like an overcrowded kind of office space. So you can see a bunch of the desks and furniture all started to spread the fire, and it's also kind of spreading along the roof and coming out the open windows. So it's really started to spread very quickly, 7 minutes, and then kind of 7.5 minutes in, the entire compartment was totally engulfed in flames. But then by 15 minutes after the fuel in the compartment had burned, so all of the desks and stuff had burned away, and a nice layer of char had formed over all of the exposed wood inside, the fire actually started to die down. So again, no sprinklers, no firefighting, no water suppression at all. 15 minutes after the fire had started and the furniture had burned away, it actually started to go out by itself. And then 18 minutes in, you can see the fire was almost already completely self-extinguished. They let it go for like 4 more hours after that. So you can see a bunch of the debris on the floor from where all the furniture burned. And you can see there's a nice layer of char on all of that, those exposed wood products that were there before. But the entire structure remained stable. They actually, after this test, lit 4 other fires on the top floor of the building and let those go for 4 hours each. So this building underwent almost 20 hours total of fire exposure without any kind of fire suppression. And it was so strong and stable afterwards. Like they didn't even budget enough money to take the thing down because they thought it was going to be easy to demolish, but it was like super strong and stable afterwards. So really just spoke to how hard it is to get these buildings to stay on fire because of the thermal mass of the wood and how it protects itself with char, and then as well as just how it remains stable underneath that. So we have these super big cross sections of wood. This is not from this test. This is just an example from a piece of wood that was actually burned in a furnace for 2 hours. So you can see that it starts to char and the char front kind of moves into the wood as it's heated, but it protects that wood inside. And so how you would design these mass timber buildings is you just add on some extra wood to the outside. It's fine if it burns, it will remain structurally sound underneath. And then that wood inside is actually unaffected and it's totally still structurally viable. So this is kind of how the idea of mass timber fire safety works. And you can use CSA 086 Annex B to calculate the fire resistance of a massive piece of mass timber just based on how long it's going to burn for. So I don't really have time to get into this, but just wanted to shout out that, as we mentioned, the code has increased the height of wood buildings that are allowed, but it also increased the different types of occupancies as well. So now you're allowed to have not only residences and offices, but also assembly occupancies like schools or rec centers. You're allowed to have care facilities. You're allowed to have retail and industrial applications out of mass timber for much larger and taller buildings. So there's different tiers of heights that are allowed and how much protection you need on the wood depending on how tall you're going. But there's all kinds of different provisions in the code now to just allow you to have more flexibility and not be forced to choose concrete or steel. You can kind of choose what's best for your project. So we do have a guide on this that we just launched this week with all the new January code provisions. So we can send you a link to that guide. It will really talk through all of what you're allowed to do in the Ontario Building Code. So there is a link here. I think this link is to the old guide, but if you do download the old guide, then we will send you the new one as well. So yeah, anyways, please feel free to come ask us for any of the slides or links or whatever. We'll be here to chat after the presentation. So just to wrap it up, why do we promote wood? It's a safe and strong building material that's natural. It's highly sophisticated. It grows for this purpose to kind of be a structural material for these impressively tall and carbon sequestering plants. And we are sustainably harvesting them in the province. We have so much wood. And if we do it in a responsible way, we can really build buildings that are putting less harm into our environment because of the less emissions that it uses to produce compared to concrete and steel. And as long as you're using proper design practices and building practices, these are durable buildings that can last over 100 years. So we want to support our Canadian economy, support our northern economy and forestry economy, and build low carbon, strong, safe, and beautiful buildings. So that's us. You can always reach out to us. Again, like Brock said, we're a free technical resource. If you have any questions or want support on wood construction, we're here to help. And that's it. Thank you.
Is there any questions from the audience? We'll break for lunch.
Covered it all.
Okay.
Yeah, so pretty much all our resources and tools that we've mentioned today are free. Some of the technical publications Brock mentioned are paid publications from the Canadian Wood Council, like the Wood Design Manual or like the Permanent Wood Foundation's guide. Like those have a small fee associated with them. But all of the other design tools and guides that we've mentioned are all freely available. Yes. So we don't know of any Ontario manufacturers that are working on it, but there's a manufacturer in the States. And yeah,
Yeah, you know the one in Quebec there as well too, right? With the wood fiber insulation board. And then we're quite excited because we are working on standards for wood fiber insulation. So Timber HP out of the US there, they're getting on board with it. So hopefully more standardization comes with it. We'll see more suppliers, and then that will help with some of the biomass and products that we could use from the forest. Thanks for the question. Okay, perfect. Thanks, Conrad.